the early universe, hydrogen, helium, lithium, and beryllium were the elements present through the process of Big Bang nucleosynthesis. According to researchers, the universe was likely filled with hot and dense plasma, but after the Big Bang, it had cooled enough to allow the protons and neutrons to form new elements. Thinking about heavy elements such as potassium, calcium, and sodium, how can we find them? Do you think of other hot places that can help to generate them? Well, if you think of a star, that's right! Our sun is a star, and stars may generate new heavy elements. Stellar nucleosynthesis is the process by which they create new elements. It is the formation of chemical elements within stars through nuclear fusion. When a medium star runs out of hydrogen, it becomes a red giant. Fusion continues, but instead of hydrogen, it converts to helium, which is used to create new elements such as carbon and oxygen. If the star runs out of nuclear fuel, the outer material will be thrown out into space, resulting in white dwarf. Eventually, the star will run out of heat and become a black dwarf. When a massive star runs out of hydrogen, it transforms into a red supergiant. It still produces fusion, which results in neon and other elements that are lighter than iron. When the star can create a fusion, it will explode, called supernova. The intense explosion of a supernova created elements such as gold, copper, and silver. There are processes involved in the formation of elements, and these are proton-proton chain reaction, Siyensikula cycle, tri-alpha process, and neutron capture. Proton-proton chain reaction is a process by which average star gets their energy and convert hydrogen into helium. It starts with proton and neutron fused together to form deuterium. When one proton collides with deuterium, helium-3 is formed. Two helium-3 collided will form helium-4. Siyensikula cycle. Carbon-12 fused with proton and form nitrogen-13. Nitrogen-13 undergoes beta decay to form carbon-13. Carbon-13 captures proton and nitrogen-14 is formed. Nitrogen-14 captures proton and oxygen-15 is produced. Oxygen-15 undergoes beta decay and produces nitrogen-15. Nitrogen-15 fused with proton and gives off helium and ends up with carbon-12. Then the process repeats again. Tri-alpha process happens in red giant star. There are two alpha particles combined to become beryllium. Immediately, there's another particle that will attach and it will make a carbon. If they collide with each other, it releases energy that some particles will attach to the particle to make oxygen. There are two forms of neutron capture, R process and S process. The S process or slow process occurs when there is a slow rate of neutron capture but a rapid rate of radioactive decay. The R process or rapid process implies that neutrons are captured at a quicker rate before they experience radioactive decay, allowing for more neutrons to be integrated at the nucleus to make elements heavier than iron. And those how stars made new heavy elements. Always remember that stars aren't there just to make our universe beautiful, but it gives us power and life on Earth.